Redeem Academy.
And instead of just having a nose that you can like pick up peanuts with, you shoot harpoons out of your nose.
Joey was throwing up and things were coming out the other end as well because he had drank the water. Yo, what is up, slime molds? Johnny here with Redeem Academy. I'm here to help you make the most of your education through content that gives God the glory he deserves. Mr. Olgers, did you just call me a slime mold? Hey, at least I didn't call you a dog vomit slime mold. We're in the middle of a unit about taxonomy. Today, lesson 4 is about the junk drawer of the taxonomy world, protists. Shout out to today's sponsor, the Wizard Cow. Did you know that 11 out of 12 Wizard Cows are subscribed to Redeem Academy? And they say that if you really want to avoid stepping in a pile of Wizard Cow poo, you really need to pick up a notebook at redeemacademy.org. I mean, those piles are huge, really giant. So today's about protists. I'm going to tell you about the 3 basic categories of protists: animal-like protists, plant-like protists, and fungus-like protists. Let's get into it. Okay, you can see in our notes here, animal-like protists, plant-like protists, fungus-like protists. The way scientists break these suckers down is how they obtain energy. So I got 3 words for you. There are heterotrophs, autotrophs, and decomposers. Now let's first add a little color to all 3 of these pictures. All right, so there we have the words hetero, auto, and decomposers. You may have heard the word hetero and homo before. Hetero means different, homo means same. So those, you'll see those come up in biology a couple times this year. And then auto means self, and then decomposer is what mushrooms do. They decompose dead things. So we go to the notes here and we have the kingdom that is the junk drawer of the living world. Most of them are going to be single cellular and they get sorted into animal, plant, and fungus-like. That's Protista. That's what today's notes are about. So an organism that gets its food by eating other organisms is called a hetero, and hetero means different, and then troph means food. So different food, they don't eat themselves. That's as opposed to an autotroph, which does eat itself. Okay, so we go back and look at our pictures over here. We have Sparky the squirrel eating a steak from another animal versus a solar panel, which is basically making its own food and eating it, which is going to be a plant in the future when you see that, okay? And then we have a third category where the thing that's getting eaten is dead, and we have a new word for that, decomposer. And we don't use the word troph at all. So let's get to the interesting stuff and actually see some protists who eat this way. So we're starting off with animal-like protists. Let's look at some different feeding strategies of animal-like protists.
How do these heterotrophic organisms get their food? Well, in spite of a remarkable amount of diversity, a lot of microorganisms use one of the same 3 strategies for getting their food. Some of this will be familiar to the macro world, some of it will not. One of the less familiar is filter feeding, which allows larger organisms to consume suspended food particles or much smaller organisms. There are filter feeders in the macro world. Baleen whales come to mind. But while a whale must swim through giant clouds of small organisms in the microcosmos, your food can come to you. Some filter feeders use hair-like structures called cilia to create a vortex that brings other microorganisms or food particles to the cell mouth. These cilia are specialized for this task, and their beating creates a current that expediently and beautifully directs every nearby thing into the waiting mouth of the microorganism.
So imagine being a filter feeder as a human. It'd be like sitting in a river with your mouth open and just waiting for the fish to come to you. And imagine if you had hairs on your body that could cause the water to come at you, and then the fish gets sucked into your mouth. You'd have to have a hole out of the back of your head to let all the water go out, and then you'd have to bite down every time you get a fish. That would be what it would be like to be a filter feeder as a human. There's actually another microorganism they're going to show us in the video in a second that pretty much does that exact thing. Every time his mouth gets full, he goes, and he bites down. Watch this. This is that creature.
Animals that use cilia to create swirling vortices around their mouth parts. You can see how successful this feeding strategy is by its belly full of algae cells. Every time its mouth fills with more algae, it contracts to swallow the food.
Delicious. I don't know about you, but eating algae all day, not my dream job. If it was Domino's Pizza, deep dish, sign me up. Now this is a freaky little creature. This guy is gonna basically poison things and suck them in. Check this out.
Is called raptorial feeding. Raptorial feeders selectively capture prey and hunt other organisms. In this video, you can see Dileptus hunting. It paralyzes one organism with a touch of its trunk-like proboscis, and then it pulls that organism into itself in a process called phagocytosis. Many of these microorganisms are armed with something called toxocysts. These are little harpoon-like structures filled with toxins, and they're located on a particular part of the cell, which the microorganism uses for hunting.
Boom, there,
These
he got him.
tiny harpoons are then fired when they come in contact with prey organisms, which then become immobilized. This is Bursaria. It's a single-celled organism with a huge mouth, and things have not gone well for the paramecium that is now
Guy just got
inside
sucked
it.
in. So this last guy is basically an elephant with harpoons on his nose.
So imagine you're an elephant, and instead of just having a nose that you can like pick up peanuts with, you shoot harpoons out of your nose.
That would be a pretty deadly elephant. That's what that last guy was.
This is Frontonia, which is a close relative of Paramecia, but it lacks the filter-feeding habits of its relatives and feeds predaciously on large diatoms and filamentous cyanobacteria, such as Oscillatoria here. Though in this case, it turns out this Frontonia bit off a little more than he could chew.
Exactly. Bit off more than he could chew. He's like, I gotta back out, guys. That was too much.
Histophagous organisms, such as these single-celled coleps, attack injured but live animals or other single-celled organisms, sucking off hunks of tissue rather than consuming whole organisms.
Just taking bites.
When they attack an animal, they enter wounds and ingest tissue, often attacking in groups because their chemical sensing abilities attract many of them from a distance, like microscopic vultures. When a number of them gather in one place, it's hard to avoid another macro world analog, piranhas, devouring everything soft in no time at all.
They're just having a feeding frenzy on a dead body of something that's still alive. This is actually what lions do, right? Okay, here we have an amoeba.
Amoeba with a suitable name. It specializes in feeding on filamentous algae. First, it bores a hole through the algal cell wall, and then slurps out the gooey, nutritious cytoplasm.
Delicious. So this is something you're gonna see in the next plant-like protists, that algae have glass walls around them. So this cylinder-looking thing right here is made out of silica, which is the same thing we make glass out of. And algae make little silica shells around themselves because it's a dangerous world out there. And that amoeba was able to penetrate that silica shell and then suck out the algae from the inside. All right, so the thing that the animal-like protists have in common is that they eat other things. They are heterotrophs. This one is called an amoeba. He moves like a blob. This one is called a paramecium, and he moves with little hairs called cilia. And this one is called Giardia, and he moves with flagella. Now, what look like eyeballs on Giardia are actually two nucleuses. Now, the interesting thing about Giardia, in America, maybe we hear all the time, I don't know, I've heard multiple times, don't drink the water. So if you're going on a mission trip, or you're going on a vacation to a foreign country like Mexico, or Uganda, or Nepal, places my church has gone on mission trips, they'll tell you, don't drink the water, be careful, or they even have these little packets to drop in the water when you're gonna have to drink it, they have chlorine in. And there's little parasites, and one of the most common, called traveler's diarrhea, or called Montezuma's revenge in Mexico, is called Giardia, and it will get inside of your gut and reproduce like crazy and give you an enlarged colon and can give you inflammation that leads to diarrhea and vomiting. And when I was in college, I was on a mission trip in Mexico. We were building houses for people in Mexico. And I was sleeping in this church on the way home. And my buddy Joey and I were sleeping in this giant church. We got like, the pastor's office was full, so we moved into the sanctuary. It was just me and him in this giant sanctuary. And sleeping in a giant sanctuary at night is kind of like, ah, it's kind of scary. And I remember I woke up in the morning and he wasn't in there with me. And I was like, Joey, you abandoned me. Turned out Joey was throwing up and things were coming out the other end as well because he had drank the water somehow, or you get contaminated. And that was when we were back in America, but he had gotten contaminated with Giardia in Mexico. And so be careful, don't drink the water. Now, I've never actually seen Giardia before, but thank you, YouTube, I looked it up. And this YouTube channel is called Med Lab Zone. So there are people who do tests for this, and this actually says Giardia lambdia, that's the scientific name, trophozoite under microscope in stool sample. So why would you, I don't know, but I guess. And we zoom forward, and somebody in the lab, check out these little boogers moving around. How could there be this many of them in this is a little tiny sample of stool? Oh, the nicest music, too. But look at all those little protists swimming around in somebody's poop that someone else put under a microscope. Yikes. And this is what a real microscope, like a regular person's microscope looks like. It's not all pretty like what those other videos we get are. Those are probably thousands and thousands of dollars of equipment. This is your $400 classroom microscope right here. But you look at your poop under a microscope and you see all these little bugs swimming around. You've got Giardia. So we come over here to the animal-like protists. All the animal-like protists use this feeding strategy. They are heterotrophic. Okay? Protists that can move like a blob are called amoebas, plural. And a type of protist that moves with cilia is called a paramecium. Now it is time for plant-like protists. You have already heard of them. They are called algae, or if you're British, algae. Now they form these amazing crystal structures that they live inside of, and they come in all different shapes and sizes. Here's one that's got the name Astro something, and so it's named after the fact that it looks like a star. Here's a bunch of diatoms, okay? And so they have these long, elongated crystal silicone shells they live in. Another funny elongated shell, and they stick together. Okay, here's a diatom by itself. This one is my favorite. It's called Volvox, and they float around with multiple cells inside of the silica case. Also, there is a multicellular form of algae called kelp, and as a kid, I would always be running around the beaches in Oregon, which are not really beaches at all because it's freezing. But this kelp would come and wash up on shore. Maybe you've never seen kelp. It's got these little bubbles in it so that it can float. So it stays afloat underwater, and then it washes up on shore, and you're a little kid, and you think, this is the most disgusting thing I've ever seen. I want to pick it up and hit my sister with it. Then your mom yells at you, and you get in trouble. That's been my experience with kelp. It's all slimy and gross. Some people actually use it to eat, which is even weirder. Maybe your mom has convinced you that seaweed tastes good. Seaweed probably tastes about the same as kelp. It's actually a multicellular protist and not a plant. So when the algae get going, sometimes they can have such extreme blooms that you can actually see them from space. So you can see how the ocean water has changed color here, and these color changes are actually visible from space. I searched around for quite a while to find a view of this, but I couldn't find anything. I don't think satellites take videos very often, so you can find pictures of it, but not videos. It'll sometimes kill fish, because it can actually become toxic when there's too much algae in the water. Okay, so here we have the plant-like protists. Here's kelp, the multicellular plant-like protists. Here's a diatom. And I forgot to tell you about the dinoflagellates, so let's label that real quick. Dinoflagellates. Okay, or that's a dinoflagellate, one. And check this out. Dinoflagellates are a special kind of bacteria that can do this thing called bioluminescence, where they actually glow. So just certain times, maybe certain water temperatures, when they're in the water and they're blooming, any disturbance to the water makes them glow. Isn't this crazy? Look at this. So people walking through the water or the waves, it causes the water to glow. It looks like something out of Star Wars. It looks like something out of a science fiction movie. The algae themselves are actually glowing. So the enzyme involved in the reaction is called luciferase, and so that might sound familiar. Every enzyme ends in ase, but lucifer is Satan's name. And so it's the fact that Satan is called the morning star, I think, or the angel of light. And so he was like an angel, and he's a fallen angel. But even, I think Paul in the New Testament says Satan masquerades as an angel of light. And so it's this connection to the fact that he was angelic, and the same kind of word meaning of light is connected to angels. Or him as an angel, and that's why it's got the same name. So really interesting name for an enzyme, which, when you think about it, is an important detail to know as a Christian, is you don't trust everything that masquerades as a good thing. You need to test what's out there and be careful. Like, don't drink the bright water because maybe it's got something bad in it. All right, so the plant-like protists are called algae, and they all use an autotrophic feeding strategy. The algae that can glow in the dark is called a dinoflagellate. And a brown algae that's multicellular, big word here, kelp. All right, now for the reason I called you a slime mold at the beginning of the lesson. The third type of protists are called slime molds. There are also water molds. I didn't even include them because they're kind of boring. Slime molds are exactly what you would expect. Slimy things that are kind of moldy. And they grow in a really funky way. They kind of pulsate while they grow. Now this is sped up. This is fast forwarded. It's called time lapse. But they have this sort of pulsating thing they do, 2 steps forward, 1 step back, 2 steps forward, 1 step back, while they grow. And they grow on dead stuff, and they're going to decompose dead stuff. And they don't like light. So they grow in dark, nasty places where things are dead in the forest. And they sort of look to me like a circulatory system of snot. Forest snot, that's what I would call them. And they grow across stuff in the fall and plan on chewing on it and making it a little more dead than it already is. Another super interesting fact about slime molds is they are actually just one giant cell. And you've seen other things that are one giant cell. A chicken's egg is actually just one giant cell. What's interesting though is when they get to the end of their life, they actually turn into like tiny little mushrooms that dry out and make their own little spores. And so those are like the little mushrooms, and those are their spore packets. And at the end of their life, they're going to dry up and release their spores into the air. And those spores are going to float around like we've talked about with spores before. And those spores are going to float around in the air and land in a million trillion little places in the forest and in your nostrils and everywhere else. And anywhere those spores land, they can grow into another slime mold next year. Now, one other interesting thing about slime molds is that even though they're one cell and they have no brain, they're really good at solving puzzles.
This species, for example, Physarum polycephalum, creates these little fan fingers that play touchy-touchy with the world. Remember, there's no brain controlling all of this. More like patterns of contractions. If you put an eye drop of food stank in front of it, those patterns change. The tubes in that area start going crazy, and the whole cell sort of reorganizes, pulling material away from the useless tubes and pumping up the ones that are connected to the num-nums. And all that pressure pushes the slime mold in that direction. All right, simple enough. The booger can move towards food, but food isn't always plopped right in front of you in nature. So what happens when a science hippie blocks the beeline with one of these barriers? So the problem here is that if the slime mold just keeps moving to where the food signal is stronger, it'll get stuck. But slime mold don't get stuck. You know why? Because it knows where it's already been. You know in the fairy tales when they leave breadcrumbs behind? It's like that, but instead of breadcrumbs, it's mucus. The slime mold leaves behind a film of snot, sort of an external map of where it's been. The mucus kind of cancels out the food signal, and it tries a new direction. Using this strategy, it can solve a maze, but
look at that! It solved a maze and found its way to the food. I love the way this guy makes videos, and he said, oh, the slime mold found its way to the food stank. So they're laying down food stank where they want the slime mold to go, and it'll solve a puzzle to get to the food stank. Now this gets even more interesting because they're gonna lay down a map of food stank and have it chase after the food stank and put some barriers in its way and see if it finds the most efficient routes to the food, and then they're going to map it out like it's a train or a subway station in Tokyo. Check this out.
What's amazing, Kilme, is that the solution it settles on tends to be the shortest path through the maze. If you put food down in a bunch of different places, it finds the overall shortest path between all of them. Remember, we're talking about a single cell with no brain. Some science hippies in Japan were like, all right, if you're so smart, try and design a whole railway system. They put food on a map at each train destination and plopped a slime mold right on top of Tokyo. Think very low-budget Godzilla movie. The slime mold did its thing, but then they realized that it had made paths right through a lake and over some mountains. So they did it clever. They created a surface that let light through where there were natural obstacles on the map.
They did a clever.
Slime molds hate light. It hurts them, so they avoided those areas. On that surface, the slime mold created this network. And here is the actual rail system. When they looked at the slime mold's solution in terms of how much it would cost, how quick you could get places, and how it did if a part of it broke, it did just as well as the one that the Peoples made, without all the college debt.
Without all the college debt. So slime molds are these amazing creations made by God that are really good at mapping out efficient paths toward food without all the college debt. All right, so these are the slime molds. They are the fungus-like protists. This big boy is called the yellow slime mold, a very creative name. These are his spores, or those are the structures that will release his spores. And this is the dog vomit slime mold. It is actually named the dog vomit slime mold because people kept thinking it was dog vomit in their yard. Now the thing about slime molds is they get food by decomposing dead things. They don't make their own energy, they don't eat living things, they decompose dead things. They are not fungi, they are not a fungus, but they do what funguses do. So all of the fungus-like protists use this feeding strategy. They are decomposers. The slime mold that pulsates while it travels is the yellow slime mold, and most slime molds reproduce by releasing spores. Big question, how do protists get their energy, and what does that teach us about the way God designed living things to depend on each other? You know, protists are microscopic, but they do all three of the things living things do to get energy, and it just shows there are things that eat plants and animals, there are things that make energy from the sun, and there are things that recycle both of them. And so God really created an interconnected world. It's like when Mufasa took Simba out on that platform and told him about how we eat the zebras, but the zebras eat the grass, and the grass recycles our bodies because our bodies are fertilizer.
When we die, our bodies become the grass, and the antelope eat the grass. And so we are all connected in the great circle of life.
God created a world full of relationships, and everybody's connected to everybody. It's like when God saw Adam in the garden, he said, it's not good for man to be alone. We're not made to be alone. We aren't alone. We're connected to everything around us, and we need to be thoughtful about the effects that we have on others. And it's good for us to be in relationship with others, both personally in relationship, but also we have these unintended relationships that we have with our world. God is a God of connections. Even God in the Trinity is connected to the Son and the Spirit. God has lived forever in relationship as a Trinity. So God is a God of relationships, and He's a God of harmony, things functioning in unity and harmony. There's so much order and harmony in the way God intends for things to function. He's a good God, and He's made a good world, and we get to look at the way He's made things, and we get to think about His design as we think His thoughts after Him. Hey, hope this was a good lesson for you. I was thinking while I was teaching this today, why do those algae shine? Put some comments in there for me. I have no idea what the purpose of those bioluminescent algae are. Like, why would it be a good thing for them to shine? Look that up. Put that in the comments for me. Peace out, brown trout.